Watching it, like, are you serious? I swear.
I just don't want to start it up and have it be wrong.
Okay, it looks like we have everything. Yeah, because you want to see the, let me just show you the store.
Yeah, it's on the resistance.
So here's your little circuit board.
Yeah, I got mine.
All these dots are connected together. Okay? you get yours hooked up?
It's not.
See, all these guys are connected together. Rows, that row, that row, that row. So what you want is your resistors from 1, 2, 3 resistors from all in that row to another. See what I'm saying? Yeah. Because you're building this. And here's one row, that's one row, that's one row. They're all hooked together like that.
Right, you know.
Should I spend my own one?
Yeah, it is.
I'm all about ABC. I don't play. Some days in my place.
No, I think I fixed it.
Okay. Reading very well. You do. And, okay, good. So, what was your question?
Is it all look like for some power?
Yeah, but you're not, see these rows are not connected to these rows.
So we can power straight,
Straight to the, yeah, straight to the yellows. There you go. Yeah, there, okay.
this one goes here.
So those three are connected there. Wait, yeah, you want to measure the voltage across those, yeah. Yeah. See, so now we just get that green one. Either way. Yeah, yeah, so they're all connected. Fire up somehow.
Oh, it was that thing? And then, do you have a plug it in both?
Okay, you're on.
These are my first ones.
What are you trying to do? You measure the total resistance, you did total current. Oh, you want to measure the total current. Measure the total in the circuit into and out of the house. Okay, turn it off. So I'll show you what you do. You have to put the end of the right here to the circuit.
I can't.
You draw it up on the board. So the power lead comes out of the black or the red, goes to the ammeter. Comes out of the ammeter, now it goes to the back power supply.
Okay, plus. Yeah, that's what I did. I
Okay,
wanted
so now-
to calculator.
Now that's in the
And
circuit.
it's all that. So I do like. You know, you'll do 1 over 1K.
Oh, wait.
Plus 1 over 10K.
Come out of there, we go to there.
Right, but like,
Come out of the
they have
black,
3 good from that.
we go to,
Yeah.
yeah, here.
One
go to
divided by
circuit.
that.
Oh, okay.
So whatever I get from this number.
And then this way.
And then the other side is now we go back to the power
Let
supply.
me show you an example. in this area.
This guy here, right?
Would it be the same if I just did it on another pepper?
No.
Is it?
Red goes
Maybe.
through here, comes out of here.
Some power.
was just working, and now it's not spent.
And then multiply that.
You'll divide one by two.
So you're measuring 14.9
Because when you do that,
millimeters.
the 1/110.
One from here.
Yeah. What you're getting is 1 over resistance to it. And so you need to divide everything by 1, or you gotta divide 1 by.
Yeah, but the whole.
14.7 millimeters.
Yeah,
Okay?
because sometimes they'll give you the kilovolts,
So that's
sometimes they'll
the-
give you the ohms.
Now,
That's the
I usually
total
like when I get
current
the kilohms, I'll
circuit.
just break it down unless I'm just too big.
Yeah.
Did you do the whole number?
Now,
Well, what I did,
so
I
it's using, now I'm saying is
One
verify
over
that.
one times two
It's
is
a lot of
what it
errors.
is. Because on the calculator,
Okay.
it's just really easy. That's my time circuit. So, when I put in 1 over 1 times 10 to the third, it automatically just do 1,000.
What is it?
Does your circuit look like that?
Yes.
Good?
Not as
Look
pretty,
like
but
that?
yes.
Good.
Not as pretty, but yes.
That's good enough.
Good enough for government work. Okay, so I've got this set for 12 volts.
Okay? Okay, good.
Just turn it off.
So what you want to do is you want to come out of the red to the meter. The meter has to be in the circuit. So where's your meter? Okay.
Get more steady.
Yeah.
Ohm rating.
Yeah, so what we want to do is we want to come out of the red to the meter. All right? Then we want to go from the meter to one side of the bank of resistors. So the current's going out of the red through the meter, coming out of the meter through the resistor.
So this is going.
Yeah, so we need, you need a clips.
Flip on here, that's all of these.
Just click the meter to the allocator. Good. And then this guy goes to one of those three, because they're all connected together. Okay, good. And then the other side, goes to here. And one of
But
those.
I've got this.
Yeah, so let's just verify this. We're coming out of the meter, we're coming out of the top bar, we're going to the meter, coming out of the meter, we're going to here, and then back to the source, okay? And it looks like, so you want to be, yeah, but that's alternating current, one pound directly. Probably 20 milliamps is good. Good, good, good. Okay, fire it up, see what you get. 14, that's about what everybody's looking at. 14.17 milliamps.
The current needs to have the powers.
Oh, you don't have a meter. Hook up your meter to it. Here, let's turn this on. So here's what we want, Alex. What we want to do is we want to come out of our power supply. With the, let's just take the red. And we want to go from there into the meter. The meter has to be in the circuit for current. So we'll come out of the, I need the red meter of your meter. Why not?
I was trying to use it.
Let's see.
Figure out.
Maybe we can make it work. So we have the red lead goes into the meter. The black lead from the meter goes to one of these resistors. So do you have a alligator clip? Yeah. we'll go from the blackening on the meter to our resistors, and now we go from the resistors back to the power supply. All right, so let's see if that's right. Then we go from the red, we go from the red to the meter, We come out of the meter, come out of the meter to the green, we go through the resistors, they're all connected together, and on the other side, we go back to the power supplies, okay? And we'll hook the meter to, we'll connect the meter to milliamps, that's direct current, that's 20 millimeters, okay? Let's fire it up and see what we get. 14.11, pretty good. That's as simple as that.
I was gonna do the same thing because like I don't want to do
A meter?
Yeah.
Here, I have a meter. So you're coming out of the power supply, the meter has to be in the circuit. So we're gonna come out of the power supply into the meter. So let me hook the red to the red. Okay, good. All right, we're coming out of the meter to a, no, because then that takes us back to the power supply. We have to come out of the meter and we have to go to the resistors. So you need an alligator clip. You need one of those alligator clips. Yeah, one of those. Gotta use them sometime, Russell. Might as well use them now.
Yes, sir.
Yeah. That's okay. Okay, good. All right, so we're coming out of the meter to the one side of the resistors, and they're all connected together. And the other side of the resistors back to the power supply, okay? So we have a complete circle. Come out, go to the meter, come out of the meter, go to one side, and then come out of the other side of the resistors back. Okay, so let's fire it up and see what we got. And this is see what we got.
14 here is our.
That's your current, 14.41.
You still touch the rolls on or
You
not?
can touch it, sure.
Okay, I thought you were.
It's not that much. Is everybody getting about 14 point something for the current? Okay.
Look at that. Mine's all over the place.
Yeah, digital.
I'm not a big fan of that. It's so much more like, I don't know.
But you got a better answer than I did. When I converted it.
What you got here?
So right now, that's one, it's 9-2.
Let's look at the total resistance.
What do you want to measure this? That's right.
I mean, you measure it.
You said we could get 11.97.
Yeah, that's good. I mean, this gives you this calculation, that gives you that calculation. When you measure it, calculate it.
What'd you get, Russell, for resistance?
I got it.
Did you want us to do this one?
Do you want to?
Particularly.
Just hang on, I want to see what we are.
The one that I went right now.
What'd you get?
Because I use this.
What'd you get?
It's just, it's all in one.
That's right.
So it's easy.
845, that's good.
This is full size type.
Those resistors can be off a little bit.
bit.
Have you calculated 857,
Yeah.
which is correct? What did you calculate?
Curve,
I didn't calculate, I used it.
curve.
Calculate it.
Y3 1 is.
You got the calculator.
Use the meter and calculator to see what difference you get. Go ahead and go through the equation. What'd you guys calculate?
I got 11.9.
I got 12.59.
For what?
For the current.
11?
Yeah, I don't know.
What'd you get for total resistance?
Oh, he's talking about the calculator with the V was not.
Oh, yeah, sorry.
He was looking at the total voltage.
Oh, yeah.
That's all I think he did.
The current, everybody's been getting about 14
Yeah, oh,
milliamps.
yeah, I got.
Oh, you got 14?
Yeah,
I got
Okay, that's
13.9.
good,
He's
that's
looking
good.
at the one.
So
What'd you get for the calculated
Yeah,
resistance?
that was 11.9.
Okay. We gotta look at the resistance here. Something's not
I
happening.
think that's in the one thing. He's looking for this. That was one. Well, that's if you look for the voltage.
Okay.
So we need to have one.
Oh, okay, okay.
So here's the here's the formula for the resistance for that circuit you just built. 1 over 1,000, 1 over 10,000, 1 over 15,000. Okay? When you do that on your calculators, you should be getting 857 point something amps, or ohms. It cannot be over 1,000, it cannot be. Because that value there is 1,000, it has to be less than 1,000 ohms.
Copy, here's your meter.
Okay, thank you.
Alex, did you finish your meeting?
No, I didn't know. I'm trying to see. No, I didn't fix it.
Doesn't know whether he said at the beginning that someone had to be returned back, something like that. Because someone was more than.
Yeah, I think,
It was like something like, yeah.
one of the other guys had a problem with this.
Is your meter not
Was,
working?
what,
Yeah.
2 weeks ago, the guy had to go return the meter?
Because his little, little lens over that LED was missing. That's like the third one that I've seen like that, so I said, take it back. Take it back. Hey guys, I have one more tidbit before we go. I'm going to go over this again next week. I just want to show you something, and then we'll reinforce it next week, all right? This has to do with power. The power of a series circuit versus the power of a parallel circuit, okay? Here we have two resistors, 50 ohms in series, 10-volt power supply. Same deal, two resistors, but now they're in parallel, 50 ohms each, 10-volt power supply. So let's calculate the power in this circuit. We have the total resistance of this is 100 ohms, okay? Because we just add the two resistors. And we have our equations, power equals VI, power equals I squared R, or power equals E squared over R. I'm gonna find the current, and then use that equation there. So I have current is equal to V over R, or 10 over 100, which is equal to 0.1 amps. So I squared R, power is equal to 0.1 squared times 100. So that's 0.01 times 10 squared. I'm dragging this out, is equal to 10 to the minus 2 times 10 squared is equal to 1 watt. Okay? Well, that was laborious. So we have two 50 ohm resistors in series, 10 volt power supply. I calculated the total resistance, 100 ohms. I used Ohm's law to calculate the current, 1/10 of an amp, and then I used this to calculate the total power for that circuit. Okay? I'm going to take those same two resistors, now I'm going to connect them in parallel. So RT is equal to R1, R2 over R1 plus R2, which is 50 times 50 over 50 plus 50, which is 2,500 over 100, which is equal to 25 ohms. So the total resistance is 25 ohms. The current is equal to V over R, which is 10 volts over 25. 0.4, so the current is 0.4 milliamps. Okay? So the power is equal to I squared R. And we'll go over this again next week, but it's 0.4 times 0, no wait, that's 0.4 amps, I'm sorry. So that's 0.4 squared times, what's the total resistance, times 25. Which is equal to 4 watts. Okay? 4 watts in parallel, 1 watt in series. The same components, same. We just have them connected a little bit different. The reason is that here we have added the resistance. And here we've used this formula to calculate the total resistance. In this case, the total resistance is a factor of 4 less than this guy here. Lower resistance, higher current. And that gives us our 4-to-1 ratio in power. So it's important when you, I'm going to go through the same calculations again next week, so you know, just wanted to introduce you to it. So just so you know, depending upon how you connect your components determines the power rating and the power dissipation, and that affects the size of the resistor that you put in there. Big resistor or little resistor. Physically big to dissipate the heat. Okay? Here's your homework for next week. We're going to be going over this again, and then I want to get into series parallel circuits. It's the same thing that we've gone over. Circuits are just a little bit more complicated, a little bit more to think about. Okay, turn in your labs on that. Oh, and yeah, and by the way, turn those labs in. I'll give them back to you next week, and we'll go over those 2 problems at the beginning.